one of us has it. Hey, someone's recording. We're recording now. Great. Neat. We did it. We're recording.
Wait,
so
does it say that it's recording?
Yeah, there's a little goofy red dingy button on my
Oh yeah, I see it.
Screen
okay,
share.
Cool.
Yeah, so dingy button, that's a technical term. So where we left off in a review of last week, we had this public static void print and then string thing to print. So all I have to do to print something now, instead of writing system.out.print line, I can just write print. I want to print this. Then of course, always remember your semicolon. Always do it because it's bonkers. Okay, so print. I want to print this. Now, last week we had a sum and we did some mathy stuff, and then we also had a method that we actually brought in. We brought in an array, and we talked about pass by value and pass by reference. And so that was a lot. And like, if you don't remember that, we're going to cover it a little bit here, but really all you should know is that all you really need to know is that if you use an integer or a character or something that starts with a small letter, like int, my thing equals 12, or char, my char equals C. Because these data types start with a lowercase letter, well, not because they start with a lowercase letter, but you can basically assume that if it starts with a lowercase letter, it's going to pass by value, which means if I create public static void do stuff, and do stuff is int x. Whoops, I'm killing it with my typing today. Then I say x equals 23. Then with a print, say x is x. Kind of neat. And to do that, so print x is x. Then say, let's get rid of my char. Print my thing is, all technical terms, my thing, my char. Very cool. Also, let me pull up the chat real quick before I do anything else. Not annotate, dang it. There we go. Cool. Now you can see the chat. If anyone has any questions, please chat or unmute yourself or turn your video on. We can all like have a video party. But, whoops, what am I doing? So we've got my thing, I print it, and then I'm gonna call do stuff with my thing, passing 12 in, and then we're just gonna do this exactly again. Cool. Now, when we run the code, blam, you see, I wanna print this because we did wanna print it. Then my thing is 12. Then we pass my thing in to do stuff, where we're really passing the value of 12. So we're just copying 12 into this x. And that's cool. And then we have we're reassigning x to 23. And we print x is 23. But because it's lowercase, we pass by value, that never changes anything outside. So when we go to print my thing has always stayed as 12. The only time this is different is with arrays. It's just, there we go, problem solved. My array, oops, I said int. So arrays always will always and forever, you'll see these square brackets right there. That's how you denote an array. So this is we're implicitly defining an array right here. So I can say like, let's 23 and 42. Cool. So now, whoop, why doesn't thing to print print? I don't.
Oh, on line 5.
On line 5. Oh, no, thing to print is printing. So when I write, so that's a good question. Maybe we should change this up a little. Instead of writing print, let's call this print func. So we can even make this a little, so thing to print does print. So that is a good question. I was like, where is thing to print? I remember that. So thing to print is just, it's a parameter. So we're storing whatever the heck, ooh, what did I do? Nope, okay. Cool, so we're storing anything. So we pass something in, and we're storing that, basically saying like, passing, I want to print this in here, and now it's getting copied into thing to print, saying I want to print this, and then printing, I want to print this. And the same thing goes for, oops, there we go, for anything that we pass into thing to print. The downside is that thing to print is taking in only, or our print function is only taking in a string. So that means that anytime we use it, we have to either pass a whole string in, or if we want to pass in something like an integer, like x, we have to say some string plus that integer, and that does a thing called casting. And you'll see more versions of casting later, but the basic thing to remember though is that we just have, we're passing these values as a parameter into these functions. If you want to get real crazy with it, which heck yeah, let's do it because that's why we're here. Right now, let's just undo this. Whoop. We renamed it print func. This is going to come in handy actually a lot later when if y'all do robotics, or if you're just interested in programming, this will come in handy all the time. There's a thing called debugging. And so for what we've been doing so far, we've just been printing stuff, and printing stuff is extremely useful. In fact, a lot of times it's the fastest way to sort of like get a quick idea of what's going on. But there's another way that's pretty dang powerful, and that's called debugging. And you might be wondering, oh, it's really hard to see. Can I make this a lighter? Hey, nice, classic. Apply. Or there we go. Nice. A restart is required for the theme. Doesn't look like it. It looks like it's doing completely fine, so we're not going to restart. It'll be great. So much easier to see in the light mode than the dark mode. So also sorry though, that probably was just like a shock to the eyes. So up here in this little corner right there, there's this thing called this little bug, and like it's an adorable little beetle. So I've wondered what that is. If you clicked on it on accident, that runs the program in a completely different way. Now, if we run it right now, that's it, cool. We ran it, nothing happened. It just ran. It's the same as pressing play. Whoops. Woof, get out of here. All right, it's the same as pressing play, but there's a special thing here. So I double-clicked line 14. And this little dot came up to the side. Kind of cool. If I press play, it still plays the program. But if I press debug, oh, what happened now? This kind of launch is configured to open the debug perspective. Let's do it, let's switch. Blam, Doesn't look that different, kind of different. Awesome. So now we have this line on the screen. That basically this allows us to step through our code line by line by line by line. So now notice that this is all different. There's no more, these aren't grayed out. If I hover over this, it says resume. If I hover over that, red stop. You all know what play, stop, and pause buttons look like. But then there's these arrows. There's step into, step over, and then there's another one that's grayed out that says step out or step return. So let's click on step into. Step into is how you step into a function. So we made a thing called print function, where it's up here. So print func, and we actually do stuff in there. So if I click step into, I actually go into that function. And then it's neat is if you hover over if you're on the green line and you hover over variables, it'll actually show you what's stored in the variable. It's a lot to kind of take in because it's just like, what's going on? And this is why people use IDEs like Eclipse or like Android Studio if you do robotics. They're very powerful because they kind of help, they run alongside the program to like show you what's happening on the inside. So we have, you can see we passed in, I'm pointing at my screen like you can see my hands. We passed in, I want to print this. And then inside of thing to print, we have the value, I want to print this. It's kind of neat. Then we press, if I do step over, it's going to say system.out.print line. It's going to print, I want to print this. And then notice we're highlighted this last little bit right here. That last little bit is just the end of our program, or end of our method. Sorry, not the end of our program. And we didn't actually write a return because this is void. We could have written a return statement, but Java's smart enough to know that it'll implicitly return and be like, oh, there's no return statement. I've reached the end of these curly braces. So now if I press step over, which is just go to the next thing, it's gonna hop out. So we hopped out of print func. Then now we're back in our main. So I say int main, or int main, int my thing, in main equals 12. And it's blocked by my chat. You might notice if I press step over. Now over here, this is part of our call stack, which you'll learn much more about this in a different class. Or if you're really excited to learn, this is called call stack, where it basically shows the variables that we have. So we just declared my thing. My thing is 12. Then we press, step over again. Or we can, let's do it again. Let's step into. We're over print func. Step into. Oops, what did I do? Stepped into the wrong thing. If you ever do this and you see a bunch of code that you didn't write, that means that you stepped into a function that you didn't mean to. Because there's lots of functions built on functions built on functions. So I'm going to click step return, which is this goofy little arrow. It looks like it's pointing out. Yours might say step out. It's possible. So it's step return. There we go. You know what? Let's just step over. There we go. Hey, we passed over with our print func. Now let's step into, come on, do stuff. Cool. Where we passed my thing. My thing was 12. Still is 12. We passed it into X. X copied the value of 12. Then when we reassign X to 23, notice over here, X is 23. That yellow line changes and kind of shows us what's going on. I think debuggers are really powerful and super neat. Then we do step over again. We step out and we go to print func. We highlight over my thing. It'll still show us 12 because my thing is still 12 over here. And then again, and then we declare an int array, my array. And didn't really mean to show this to you yet, but we're already here, so let's talk about it. And I know this is very, I wish that you could like make the text bigger. One of these days I'll figure out how to do that. But if you look at my array, inside of my array, if we click on this little drop down chevron thingy, it shows us the index 0, the index 1, and then it shows us the numbers 23 and 42. Well, heck yeah, we made 23 and 42. So this is just letting us peer inside of our array. But notice how at my thing right there, that just says 12. That's the value. We have my array, and it shows us this ID. That ID is really cool, but that's the reference. That's where we would say pass by value and pass by reference. So right there, what we're doing is when we actually go to pass a reference, and I'm going to stop right now because the program's over. So when we pass to a function, we pass by reference. So say public static void, right, overwrite array. It's going to be an integer array. R, we're just going to call it R. Pirate's favorite data type. R. That's so stupid. I'm so sorry. Do a quick for loop. I is 0. I is less than r dot length. Then, oops, I plus plus. Then all we want to do, oops, also is properly spell length. I'm sure you're all much better at spelling than I am. Like, it's the worst. So we do r dot length, and then r of I equals, let's make it equal 300. It's a cool number. All numbers are cool numbers. And then finally, well, it doesn't look like it. Sorry, somebody just pinged me, but I don't see it. So if that was anyone in this room, enter it in the Zoom chat, not the Slack chat for now. So now we're going to type overwrite array. And we're just going to pass in my array. So we're going a little slower because now we're going a little bit out of order, talking about references and IDs. This will make, hopefully it'll sink in when we start talking about classes here in a minute. But so we've got overwrite array. So let's quickly write one more function, one more method, sorry, called, we're going to do public static void print array. And it's going to be a print. We're going to print an integer array. Then we're throwing a lot at you, but why not throw more at you? So up till now, done I 0, I is less than r dot length, sure. And then I plus plus. And then we would do, say, print I of, I r of I. Could do that. But I did something, oh yeah, we renamed it print func. It's good to use the names of the functions you actually create. Super cool, awesome. But so a lot of times when you're writing code, writing out a full for loop for some things, you don't really need to do that. It's good to get used to how this looks, but Java lets us do something called a for each loop. And this is kind of really weird syntax, but it's just the way that they wrote it. You'll eventually get used to it. Say for int I, and then a colon for in ara It is. You might think that's crazy. Hold on. Well, shoot, let's do this. Let's just do two comparative functions. So say print func printing with for each. Also, all of this code will be posted. Don't want y'all to be like, what's going on? And then print func printing with a basic for loop. Both are equally valid. I like this just because it's a little bit shorter, but let's take a look at what happens. So before we do anything, let's not even overwrite the array. Let's just print array, right? Yeah. Call the print array, not ara, my array. So we got this. I hit play. Oof. All right, hold up. Get out of here. Clogging up our junk. So hit play again. There we go. Bam. Printing with our for each. We wrote I colon. Then I said for int I in array. What this is doing, well, let's take a look. Compare the two. Then in our for loop, we're printing I is 0, and then we're doing ara. I am changing this. This is killing me. Array. We're just going to call it array. Array, array, array. Beautiful. Now we can say array instead of ara. So what's happening is that in our for each loop, we're not actually creating an index. We're not accessing our array by an index. What we're doing is creating this is a little weird, but we're just creating a copy. We're pulling out, extracting a copy of the data in the array and just saying like, all we want to do is look at it, grab it. So for every single element in this array, whatever I call it here, show it there. And this is awesome, especially for printing functions. If we wanted to actually like mutate our array and like change stuff, don't use for each loops. That's what you want to do something like this for this for loop. Or say, we actually get the actual index and then we can print it out by its index. For print functions, totally cool. Let's see this right now. So we have print array. Let's just and then so we print. Then we're going to write overwrite array. Also, fun trick. I just did it. I don't think I've mentioned this yet. Overwrite array is long. To type out overwrite array every single time, it's going to take up time. Time though you don't have. I guess we all have it, but you know, who wants to spend their time typing? We can just type the first few things I'm going to write over. And then if you press on, if you're on a Mac, oops, well, it doesn't really matter. If you're on a Mac or a Windows machine, press Control Space, and then it'll give you these options on how, like what you want to choose. The very top one is overwrite array, which is what we wrote. So I'm going to say, heck yeah, and just hit enter. And then I can just type in my array. There we go. And finally, print array. My array. So there we go. So now, check this out. We have okay, well, sorry, my computer's going crazy. So we have this overwrite array where we're dang it. There we go. Gross. Sorry, everyone. That was the worst. So this overwrite array, we're passing our array into, and because we have an array with a reference, an ID, we get to overwrite it. So let's take a look at this with our debug modes. Click on the bug, blammo. Then what's happening? Well, now also, if you notice, I can't zoom in. Now it says ID equals 18. That was different from what our ID was before. Don't worry about the ID number at all. That'll change. That's just a good way for you to know. If you ever see this ID there, then you know that it's a reference variable. And also this is for ours, not even Carbit. So now let's step over. So my array, ID 21, it's got 23 and 42 in it. We step over, we print it with our for each loop. Now let's step into overwrite array. Still got the same ID. So now I is 0, and we're assigning we're reassigning the data. Now I1, so we're going to reassign 42 to 300. And now we're done. Blammo. So basically think of this guy as like home address. I don't know. That we're pointing the code to a specific spot to overwrite. It's a little confusing. You'll get used to it over time. It's no worries. And then the final bit I wanted to show you about for each loop before we get into classes, because that's already 5:10. Oh my gosh. We printed it out. You already saw what changed up here. The final bit before we get to classes. And let's not even bother with the passing by reference and passing by value stuff. Let's just look at using a for each loop to see if we can overwrite an array. Int I in my array. And I just want to say I equals 200. That's it. Whoops. Heyo, terminate. You know what I didn't do, everyone? And this is really good to know. When you debug or when you are running code, oftentimes, well here, let's see debug. Oftentimes, you might forget about it. Hit debug again. Again, third time, fourth time, fifth time, sixth time. You might be noticing that nothing's really changed. Let's say I go through the program, do all this fun stuff. Cool, got printing. And ignore the rest of this for now, but then I keep going. Oh my goodness, there we go. Cool, program's done, right? You think that the stop is grayed out, but because I clicked that debug a million times, we have all of these other processes running. So I have to go through and stop every one. And if you're careful, you won't have to deal with this, but I once, excuse me, I once had like 30 processes running. My computer's fan was going and I was like, what's wrong with my computer? It's so slow. Turns out I was running a bunch of programs all the exact same time because I just wasn't paying attention. So if you do want to do debugging, be careful with this. That's all. Anyway, back to it. What happened? Blam, right here. We tried to overwrite our for each loop, or we tried to overwrite our array in our for each loop. For each loops are really only good. What's it only good? A lot of times, if you just want to view what's in like an array, that's it. Excuse me. Don't ever try to reassign stuff because you're just gonna run into problems. this really messed me up whenever I was trying to figure stuff out a long time ago. But anyway, that's just a good thing to know right there. But now, finally, like 20 minutes later, what do we want to do? We want to see how classes work. Classes are the backbone of Java, and you're probably like, yeah, we've already seen classes, public class main, and you're right. This is our main class. Everything in Java is a class. Well, not everything, but like all files are classes, and the functions in them are methods. Static functions, which essentially is our main function, is static. It's the only one that can exist, so we can't declare a second one anywhere. But it is good to know the difference, or the difference. It is good to know that there can be only one if there's ever a static. So, well, here, it doesn't really matter. So we're going to try something new, and try something new. We are going to hop over to our class example, click into our default package and right-click. This is the directory that we're in. Right-click default package and go to new, and then new class. New class, what is this new class going to be? Well, I'm pretty boring right now, so I can't really think of anything off the top of my head. I'm just gonna say person. And then leave public, and then leave don't click anything else, just name it person with a capital right there. In fact, if I made it lowercase person, it should complain at me. Let's make it lowercase and change it later. Okay, cool, made it lowercase person. You're not complaining. Okay, weird. All right. Hopefully your Eclipse is complaining at you if you tried to make it lowercase. The general consensus is the wrong word. The general protocol is for all classes to be named with capital letters. Eclipse should be kind enough to complain at you. And now that I've changed this, you might notice that Eclipse is now complaining and saying like, hey, the public type person must be defined in its own file. What does that mean? Ultimately, that just means that if you have a class, that class name has to be the same as the file name. So now I've got capital P person.java with my capital P person class. So, how exciting is this? We're finally doing it. Every person has what? Well, so I guess before we go even there, it's really hard to describe all of this because everything kind of sits on top of everything else. So I'm going to draw some stuff. So a class is kind of like, this box is a class. Just go with me here. A class is kind of like a definition for some sort of data that you want to model, right? So I'm going to say person and just do purse. There we go. So every person has a name, birthday, just say birth, a star sign. I don't know anything about astrology, but it seems fun. A moon sign, I think that was one. Let's say moon. And then all sorts of other stuff, social security number and whatnot. Think of a class. So when we declare person here, think of a class, ultimately, it's just a big definition so that whenever we create a person later, so if I say, I want a new person, and then in our actual code, declare a new person, I can then fill in the name with Matt. My birthday is February 4th. My star sign is Aquarius. I should say Aqua. Moon sign, no clue. That's a thing though, I think. And then my social security number is 1, 2, 3, 4, 5, 6, 7, 8. That's not true, but you know. I'm not going to give away my social security number. And then we can keep reusing this. Have another person. This is terrible. Then that'll be Darius. And Darius, I don't know your birthday. When's your birthday? Tell me your birthday. This has all been an elaborate ruse to figure out Darius's birthday. Oh, 5/24. That's coming up.
Yeah.
And I don't know what I'm going to say. Taurus. Are you a Taurus?
Nope.
Dang it.
Gemini.
Good enough. Taurus it is. And then again, you know, social security number. So we just didn't get to declare this once over here. We say this class, and then we get to basically treat that as a definition so that we can see all these different things. So let's, now that instead of you get to see, how do I clear this? Oh my gosh, hold on. Let's get to watch this terrible drawing all day long. There are the trash can, clear all drawings. Okay. So, oh, dang it. How do I get back to being able to write? Cool, all right. So now let's try to do that in code. I already figured what we made. So I say string name. So very much unlike our main function, we're actually like declaring variables in here. So we have string main name, not main. So we have name, string birthday. Also notice we're putting semicolons after each. String sign, then int, I'm just gonna do int, SSN. Cool. So we're just gonna start with this. So now in main, whew, so much stuff. Yeah, we'll leave it. And by we'll leave it, I mean, ooh. You know what we're gonna do first? I'm a liar, we're not gonna leave it. Public static void. Review. Review pass by value. Swoop. Technical sound. There we go. And we don't even need to leave this commented because this is just a function. I say public static void review pass, all one word, review pass by reference. Ah, look at this. Beautiful, beautiful. Now, the code is not in our way anymore. It's just there. Then finally, in the event that you get tired of seeing a screen of code because you don't want to pay attention to it, you want to pay attention to what you're doing, you can click these tiny little minus signs. I don't know what they're called. Look at that. Oh man, awesome. Now we're back in our main function. Whoops. We're back with just our main function, looking clean, looking good. Keeping your code clean isn't necessary. But I know Darius can attest to this. I can attest to this. Anyone who's been programming for any amount of time can attest to this. Not having a cluttered like workspace full of code is really helpful. Oh no. I don't know if Darius, how do you feel about that? I like having no code on the screen.
No, I completely agree.
Yeah.
I say we worked on the same team together. And
yeah.
I think we would have murdered each other if we had to take more.
Yes. Yes. See? And we're still here, so, well, I'm still here. I'm, not murdered. Thank you. That was a good time. Team Goat, greatest of all time. Miss those days.
Yes.
Oh man. Anyway, so we have this is like the biggest step of all of Java, right? Is writing a class. So up till now, I could say things like int my number equals 23. Cool. Not that exciting. But now we can start, you can, with classes, define your own data types. So I say person, person, Matt equals, then this is a thing that's going to be mind-blowing, right? I'm going to say, or mind-blowing? It's not mind-blowing. This is new to us. Say new person. And then you put these parentheses after it. That's, you're doing a thing called invoking a constructor, which we'll see in like 10 minutes how this all works. So now, of course, we're going to create another method. Well, you know what? No, we're not. I'm a liar. We're going to do something way cooler. I'm just going to say print Matt, and then Matt is an object. It's not, Matt is an object of type person. So I want to say, I'm going to print name, just name. Oh man, every time. I was just like, why is that not working? Then let's do another one. Print func Darius.name. It's gonna happen. Null and null. We don't exist. Ugh, what's happening? So when we call our constructor, we never declared. Also, cool pro gamer move here. If you're on a Windows machine, hold Control. If you're on a Mac, hold Command. Little goofy little like squiggly dude. And then click, and it'll take you exactly to where you want to go. We never wrote a constructor in here at all. Doesn't exist. So what's happening behind the scenes is there's a default constructor just building this, allocating all the memory for, you know, our name, our birthday, our sign, our social security numbers. We're not actually doing anything with that. We're not assigning anything. So what I could do is I could say Matt.name, you guessed it, at Darius.name equals Darius. Also always remember your semicolons. And then we could say, or dot birthday equals 4 Darius.birthday equals 524. That's a good 4. There. And also birthday, geez, birthday. And we can do this, we could do this for every single one, and that would be fine. Just no one's stopping you. There's no one stopping us from doing this very tedious work over and over and over and over and over and over and over again. But it's a lot better ways to do it. Maybe not better, faster. And one of the whole points of writing code, or when you get better and better at code, is being faster at it and being more efficient with how you're coding. And that leads us to our constructor. How do you write a constructor? You use the exact same name of the class. You don't need to write anything else. I'm just gonna write person, open parentheses, close parentheses. There we go, done. All right, system.out.println, because we don't actually have that print function in this class. Then I'm gonna say, in the person constructor, constructor. Okay, in the person constructor, And then name, default name, which is very exciting. Birthday, January 1st. Sign, sign. SSN, I don't know what January is. Zero. It's 0. You are the default person starting at 0. There we go. So now, before we even do any of that, I should comment that all out. Now if print, so we make person Matt, person Darius, and when we call the default constructor there, we're in the constructor. We then assign all of these defaults to our program. So now Matt is named default name, birthday January 1st, sign aside, social security number 0. Darius is named, oh dang it, come on. Darius is also named, default name, birthday is January 1st, sign aside, social security number is 0. Super cool, super fun. Also, not very helpful, except for the fact that you then don't have nulls running around if you just created it basically allows you to create defaults. For names, birthdays, not very helpful, but could be helpful elsewhere, maybe. In order to get around that, we would to assign our names and our birthdays, we'd still have to, overwrite it with all of this. And of course, now is the point where of course, there's more to it. It's lying to us. No, well, lying is the wrong word. I was purposefully withholding information. Now, just like functions, remember we had from last week, that was the one thing I skipped. Ugh, okay, from last week, we had, if you might have noticed, remembered, we had a function with the same name. Let's say public static void print func, same exact name as this one, but this time it's going to take in an integer. And it's going to print that. It's not a very useful. What are you complaining about? Where are you? System.out.println thing. Oh, okay, cool. I just had to save. Nice. So this, typically speaking, if you have two functions with the exact same name and they take in the exact same parameters, that's going to cause your compiler to say whoa, hold up, you can't have two of the same thing. Twins aren't allowed in programming. But what's happening is you're doing a thing called overloading, and it's slightly different for the compiler because it sees that, sure, you have the same name, but you've got a slightly different signature. You're passing in a string in the thing to print. Whereas this one, same name, but it's not passing in a string, it's passing in an integer just called thing. So that's function overloading. It's a quick reminder from that. But in classes, we can do the exact same thing, but with constructors. So that way, I can make another constructor called person, fun, then say, what do I want? I want to pass in a string. Well, now I'm going to pass in a name, a string, a birthday, string, a sign, or I shouldn't have done sign, then int and SSN. Cool. So now then I can say name equals a name. Birthday equals a birthday. Sign equals a sign, a birthday. Dang it. One of these days I'll be good at typing. Then finally, SSN equals A and SSN. Awesome. So, what do we got? Don't want to do that. It's going to take way too long. You can do it all in one line. Say, Matt, first parameter. Second parameter, what's my birthday? 24. Shoot, third parameter, Aquarius. And fourth parameter, SSN. Nice. Now we can just pass in. Do the same for Darius. Not Pisces, whatever. It's fine. I don't know if that's how you spell Pisces out there. Good enough. Good enough. Cool.
Close enough.
Yeah, right. We did it. So now if we do this, we hit play, blam. Now we've removed all of that code from this space, and we don't have to constantly rewrite the same stuff over and over again. We wrote that code once as a constructor, and we got to access it multiple times. So right now, I want, well, you know what? Oh, man, how do we always wind up so low on time? It's wild. So before I make y'all do a really quick, fun, exciting exercise, there's one more thing, two more things, really. So thing one, we've got print func. We're just printing the names. It would be crazy if we wanted to like have to print name and birthday. We wanted to print everything out because we have to like access all of this stuff over and over and over and over and over again. And as you might have put two and two together, there's a way to do that in our class. So we've created these constructors, which are really just fancy methods that are just allocating memory and doing all this stuff. And of course, if we can create constructors and like just these things, we can also create methods. I can say, I can create a method. And instead of writing before in our main function, in our main class, we have all these public statics. I'm just going to write public void, no static at all. Ah, boy. Hopefully we'll have time to get to exercise. So public and no static, public void, print person. It's not going to take in any parameters. All I want to do is say, system.out.println name, system.out.println birthday. I don't know why I can't spell birthday. System.out.println sign. Finally, system.out.println SSN. Then SSN. Cool, we did it. Except you should also make sure, even though we have SSN, this guy is capital, this guy's not. All right, cool. So now, you might have guessed it, instead of trying to print out person dot, name, or, well, not person, Matt.name and Darius.name, now we can just say Matt.print, whoa, and Darius.print person. Here we go. We wrote the code once, now we get to access it on every single one of these persons that we create. We hit play, beautiful. Whoa. I have a beautiful smiley face. Yes. I was like, what is that? What could that possibly be? Okay. So we've done this. And up till now, let's create one final thing. This is probably going to take all the time anyway, but maybe not. Fingers crossed. Let's just money, pocket money. And then zero equals, oops, some pocket money. What's what we'll call it. Finally, and some pocket money. Cool. Oh, there's two things I really wanted to hit. There's never enough time. So now that we changed this, though, we changed this constructor to add one more thing. You might notice over at our main, if you're following along writing code yourself, our main function now has this red little X next to it, which means that there's an error in there. Our person definition is busted. We don't actually have a constructor that takes in only 4 arguments. Our constructor now has to take in more pocket money. And well, I currently have $0 in my pocket. Darius, how much dollars do you have? How much dollars? Whoa, talking is hard. You know what, Darius, you have $500 in your pocket right now.
Oh, I do? What?
Yeah, I'm here to just. That's what I'm imagining that, you know. Imaginary fun bucks. Oh, we can buy so much. So we've got all this money. Oh, and finally, we should probably update our print person. As you might have noticed, this is why I like creating print functions, because writing systems with the print line all the time is the worst. Pocket. Oh my, there we go, pocket, jeez. Okay, cool, we did it, great, great, great. And you know what? Let's just, for the sake of it, here's another fun trick. Print system.out.print line, print an extra line, but we want an extra line on top of that. So we could just do an empty system.out.print line, or we can just add this thing, \n. Whoa, hey-oh, save, there we go. So now, I run this extra little bit. Ooh, oops, cool. So now, getting back to the whole point of all of this, suppose that you wanted to write some code where there's only one specific point in memory, such as, think of, you know, our main function. There can be only one main function. Or suppose Darius and I had to share all of our money. We were on the same team together. What do we do?
I guess that's only fair.
Yeah, of course, right? Why wouldn't we? So this is right. This is where static comes in. So static things, static methods, static variables, there's only ever one of them in memory. Because this whole time you might have been wondering, like, why did we say public static void when, you know, when there was, you know, or why do we say public static void in one and not the other? This is because this thing right here is referring to it's referring to a specific person. We're saying person or public void print person, and we're printing, you know, either me or Darius. Whereas if I wanted public static void, if I tried to print, we'll just call it print money. I do money is, I could print pocket money. Cool. But what happens if I try to print plus? What's that? This is going to give us a big red squiggly and say, change SSN to static, because, and again, this is this is going a little further than we need to, but because if you have a static method, you can't access non-static things, because your static method is looking at one single place in prop, or in your one single place in your person. It's looking at a single place in memory where that static integer pocket money is stored. So how does this work? Ultimately, of course, because we love annotations here. Draw, yes. All right, so two people, me, Darius, and we have, names. Oh, I should not put name, birth date. Oof. And then all the other stuff, don't need to watch me try and scribble this out. And then at the very bottom, we said that we had this, static int pocket money that we see up there. What's really happening is that there's an area in memory called, pocket money. Oh, POC, we're just gonna leave it at POC. That both of us are looking at, so that when I add money to the account, like let's say it's initially 0, say over here 0, 0. If we add, $10, both of us are looking at this exact same place in memory. So then each of us are essentially sharing those $10. We're sharing that place in memory for our classes to access. So let's do this with code after I clear the screen. There. Oh no, how do I, annotations. How do you get out of these? There we go, okay. So how does all this work? Let's go to main. Ooh, hold up. Save, always save. Don't forget to save. So we printed our persons, and I'm gonna say Matt dot pocket money plus equals 23. Plus equals is the same as, I think y'all have learned that, I think. I don't know. It's the same as saying we're assigning, instead of saying equals 23, it's just gonna overwrite it, which initially it's 0, so it doesn't matter, but well, it's not initially gonna be 0. See if y'all can figure this out. Let's leave that at plus equals 23. This is the same as saying, equal, I'm assigning to pocket money what I had in pocket money plus 23. Plus equals is just a shorthand way of writing this. So we have print func. Print func. Before, here we go. After. What's gonna happen? Oh my gosh. Ah. Before, Matt, 500. Where did I get $500? I don't know. Darius, 500. After, Matt, 523. Darius, 523. What's going on? Oh my gosh, so much. So, what's going on? Maybe this will. Try this out. Ooh. So if, all right, instantiation. I think that's spelled right. Doesn't matter. There we go. We instantiate. I have $0. But because we then made Darius, or we instantiated Darius as a person with this $500, and then we saved that into Pocket Money. And because Pocket Money is static, that means that I get that $500 too. Right? Well, I don't get it too. We're sharing that. We're sharing this specific thing. So there's really just one place in memory. And in all actuality, I'm gonna tell you this right now, the only time you, oh man, the only time you really need to worry about this, well, you're probably not gonna be writing much static stuff. Think of static as, there can be only one. Static is the Highlander, which that means nothing to y'all. You should watch The Highlander, it's a great movie. Ask your parents. But yes. So finally, penultimate finally, we have the static void print money. When I call, when you write, all right, mat.print money, and then all right, Darius.print money. There's not multiple, what are you complaining about? Yes, we want to access it in a static way. What are you, well, it's a warning. It's giving us this warning right here and telling us that this is static. I'm not really sure why it's giving us a warning. Maybe it's just trying to tell us, like, probably didn't mean to do this. But when we type print money, or this is a better example. So I say Matt.printPerson and Darius.printPerson, both Matt and Darius as these objects there's a print person function associated to each, because there's a static function called print money. Matt and Darius are actually sharing that function too. So this is probably something you're going to run into on accident, because you will no doubt, from writing public static void functions in your main function, you're very likely to accidentally write public static void or public static, whatever in your classes as well. So that's static versus non-static. Really, if you're writing a class, ditch the static. For like 9 times out of 10, 99 times out of 100, you're not really going to be using static that often. It is really good to know though, because when I first learned how to, when I was in my Java class, I had no idea what I was doing, because I was putting static everywhere and it was breaking all this other stuff. So it's good to be aware of when you want to use static and when you don't. Use static with your main function in your main class. If you're declaring your own classes, don't use static unless you know that you want to use static. So, final bit, and oh man, I don't know where the time goes. It's insane. It's legit insane. Final thing, when you are Googling, when you're Googling stuff for your, you're Googling things for classes, like, hey, how do I make this constructor do this stuff? You're going to come across a very fascinating thing. And you're going to come across people writing what we're going to write. We're going to write a constructor that is the exact same as the constructor above. The exact same, but just with slightly different parameter names. So string name, string birthday, string sign, int SSN, int pocket. Oh boy, you type stuff out, the words don't look real anymore. Pocket money. Whoops. Why are you complaining?
You have an extra semicolon. I mean, wow, extra comma next to string.
String, thank you.
Yeah.
That would have taken way too long to find. He's like, this looks perfect. Everything I type looks perfect now. Oh my gosh. Ugh. So Cool, we've got, string name, string birthday, string sign, SSN, pocket money. I want to save that. So if I write name equals name, birthday equals birthday, sign equals sign, SSN equals SSN, and pocket money equals pocket money. This warning, because this is not how you do it, but you might be curious to see. So it says the assignment to a variable, the variable name has no effect. What that means is we're assigning parameter name to itself, which is not that helpful. But how would I assign the parameter name to this name? This name. There is a thing in classes that when you Google, you'll see it, and it's going to be confusing for a minute, for a long minute. So I recommend, well, before we go any further, I recommend this way up here. Just name your parameter something different. And then you notice that like on the left side, there's blue. On the right side, there's gold. Gold is the color of the parameter. Blue is the color of your class variable. However, because you're going to see this when you're Googling stuff, don't get freaked out. If you notice here, all of these are gold, even though I want to access blue. And that's a thing called scoping, because it thinks that we're trying to access what's in the highest scope, just person. Think of scopes as curly brace, like curly brace mountains, like up here. Oh, let's do this. Oh boy, what did I just do? Okay. Curly brace mountain. Higher up in the curly braces, we can access name. I can't write a name out here because it's lower on curly brace mountain than here. It's a stupid idea, but you're going to remember this later on and be like, oh yeah, curly brace mountain, and be like, good mnemonic. That's how I learned. I was told about curly brace mountain. But so we've got name and name, they're all gold. To access these, we're going to have to use a keyword called this. I'm going to say this dot name, this dot birthday, this dot string, this dot SSN, and this dot pocket money. And don't be freaked out. It's not, get out of here. Why are you highlighting pocket money? Whatever, it doesn't matter. Ultimately, what's happening is you're saying this to mean the specific class object you're creating. So this dot name is being assigned the name from the parameter. This dot birthday, and also the coloration helps. So the blue birthday, this guy, is being assigned the gold birthday, the parameter. This dot sign, blue sign, being assigned the gold sign, the parameter sign. The same goes for SSN and pocket money. Totally cool to not do that, to do it like this right here. Oh boy, no, don't. Come on, man. It's the only time you really want to use this is if you have parameters and class variables named the same thing. Some people try to avoid. So I personally try to avoid it because I think it's a lot easier to mess things up. But some people swear by it. Do whatever you like. I prefer this method because the parameter names are different from the class names. There we go. already 5:58. It's insane. Well, crud. That was a lot. That was pretty intense. Do y'all have any questions? That was classes can be a lot. Well, this is going to be a stretch, and by a stretch, not going to be a stretch at all. Your homework, what? It's not to do person or something like that. Your homework is to create a class. It's a shape. And your shape, such as, rectangle, will have to take in well, not a rectangle. Make your shape a square. It'll be easier. Take in only a single line or a single bit, height or width, doesn't matter because it's a square, same thing, like length. What you need to do, and we'll write this out. In fact, here, let's just do it right now. Right at the skeleton, I mean. New class, square. It's killing me. Cannot type. So you want to have class variables for length, or I guess side length and area, but only have a constructor for, or that takes in parameter for length and derive area from that. Then have a second constructor, because why would that, you not want that? Have second constructor, okay, takes in parameter of area and derives length from that. Oh, hey-oh, oops. And perimeter. Then methods that return each value That's it. Give that a go. Square. Square. Square.java. There we go. I think if you can do that, I think you have a pretty good grasp of how classes work. So give this a go. I'll both post it right here in our chat. Whoa. Thought we could just literally copy paste it if you're feeling it. Or we're gonna post it in Slack too, along with everything else. But before then, before we go, if y'all have any questions, thoughts, concerns, hopefully we didn't go too fast. But this is a lot. The classes are a pretty classic point where people start to struggle with kind of grasping how this all works. I like to think of it more as just a big definition for how to store data, but it takes a little bit of mind bending to get there. Okay, well, if there are no questions, reminder also, Thursdays, Mr. George sends out he'll post a Zoom link, but if you have questions or if you want to like kind of jump ahead, or if something doesn't make as much sense as it did, please hop into the office hours, ask questions. I mean, that's why we're here. Yeah. Beyond that, though, thanks for hanging out. Happy Tuesday, and we'll see y'all either Thursday or next week. So with that, see y'all soon. And also back in the main room where we're going now.
Okay.
Did I just hear? Ooh, is somebody doing some cahoots?
No. Office hours.
Oh, okay.
That was fun. Very loose.
Oh, they
So-
stumped it. Matt, you're still recording.
Oh, am I? Heyo.